All right, so I've already shown you a little bit of this before just when it's come up in some of our factoring problems, but today we're going to focus on which problems are easier to solve using square roots. And you also just need to know how to take square roots, how to simplify them, and deal with them, because we're going to be using them a lot more tomorrow, and you're going to use them all the time in both geometry and in Algebra 2, especially in geometry, so we really need to make sure you have this skill down now. All right, so the first thing, now that you've already labeled your notes, the first thing that you're going to want to go ahead and write down are these perfect squares that you need to have memorized. So I'm going to scroll up there for you. These perfect squares right here, all those V's are square root symbols. I can't type a square root symbol on my keyboard, but all of these square roots here are ones that you should already know and you should have memorized. One thing that I didn't make a note of here, and you can make a note of this, is that I have just written the positive versions here, which you need to know, but remember we've already talked about that when you take the square root of 1, it's really plus or minus 1. There's two different options there, because you can either do 1 times 1 or -1 times -1, and both will give you a positive value in the end. All right, so let's look at simplifying some square roots that are not going to be in this set, because we're going to talk about how to do that without a calculator. All right, so simplifying radicals down here. I've got 5 quick examples for us. All right, so what we want to do, is to determine, are there any perfect squares within the numbers that we've been given? So for example, this is going to be the square root of 18. Are there any perfect squares in that list that we gave that divide into 18? And hopefully if you think about that, square root of 9 is one of those perfect squares. We've got square root of 9 and square root of 2. And hopefully you realize the square root of 9 is 3. So another way to write this would be to say 3, right? That's what my square root of 9 equals. And since square root of 2 doesn't equal any like specific or exact value, we just write 3, goodness gracious, 3 square root 2. All right, so the 3 comes from the 9 and the square root 2 just drops down. All right, so that's an equivalent version to the square root of 18. All right, similarly with 28, we're going to think about, is there anything that goes into 28? Well, I know 4 does. That's a perfect square. So 4 times 7 is 28. Well, the square root of 4 is 2, which must mean that this is equivalent to 2 square root 7. Okay, 10. I can't think of any perfect numbers that go into 10. The only thing I can think of are 2 and 5, and neither of those are perfect squares. So the only thing I can do with the square root of 10 is just write it as the square root of 10. It doesn't get any simpler than that as far as simplifying goes. Square root of -4, this right here is going to be not real. When you get to Algebra 2, you're going to figure out how to actually simplify that further, but you can't come up with anything that's going to multiply by itself and give you a negative number, because the only way to get a negative number is to do a positive times a negative. So in this instance, you would just say not real. All right, and then this last one, if you have a fraction, what you can do is break it up on the top and on the bottom. Now the square root of 9, here, let me scroll over here so we can kind of see this one a little bit better. So the square root of 9 we know is equal to 3, and the square root of 8, I need to break that down, which means I need to think about those perfect square numbers. The biggest one I can pull out is a 4. The square root of 4 is 2. All right, so this one, you can kind of follow my writing here. Hopefully you can get this organized in your notes. The top is going to be 2 square root 2. And the bottom, the square root of 9, is just 3. So this is the simplified version. Now, I know some people look at that and they're like, well, that's not simplified. That looks way worse. But we're going to be doing some things with it later where it's actually going to be helpful for it to be in that format and not the format that it was in before. Okay, so the next thing we want to talk about is why is it that we would choose to use square roots and not use factoring? Well, first of all, some of the things you're going to get to are not going to be things that you can factor, and that's kind of a little bit what we're working into right now. But a lot of times taking square roots, well, not a lot of times, but sometimes taking square roots can just be a lot quicker and a lot simpler. So, for instance, if you go ahead and look at questions B, 4 and 5 here, and I don't know if you can zoom in on that, but if you look at those, hopefully you notice kind of something like distinct about those. All right, so if I look at each of those problems, I notice that all of them have an x squared, but they don't have any x term, right? They have an x squared and they have like a number by itself, but no x term. So what we want to say here then is that why is it will we choose to do this instead of factoring? And we want to do that if we only have an x squared term or a number. Or we're going to also look at examples where we have like x plus h, something in parentheses squared, and still just a number. In other words, there's no extra x's hanging around. So you want to have that. That's a super important thing to have in your notes so that when you look back, you remember why it is we're choosing this method versus something else. So let's go ahead and look at a few of these problems. All right, so in this problem, 2x squared minus 8 equals 0. In this case, because there is only an x squared, we actually don't want it to equal 0 anymore. We want to get x by itself. So the first thing I'm going to do is I'm going to add 8 to both sides. That's going to give me 2x squared equals positive 8. I'm going to divide by 2 and get x squared equals 4. And then I just need to take the square root. And remember what we've talked about, because this is x squared, we should get two answers. So the answers are x equals positive 2 and x equals negative 2. Or a lot of times, especially when we're taking square roots, we're going to write that x equals plus or minus the square root of 2. This right here is read plus or minus. And they write it all as this one thing, but when you read it, you realize that there should be two separate answers there. All right, let's maybe do another one that doesn't work out quite so nice. All right, if we try another one like that, again, this is just x squared. There's no term that has an x in it, so I'm going to go ahead and try to just isolate x squared. So I'm going to add 9 to both sides. That's going to give me 5x squared equals 11. I'm going to divide by 5. That doesn't divide, so I'm just going to leave that as x squared equals 11 over 5. And then I know I need to take the square root. And when I do that, I get this gross-looking fraction here, all right? We've got x equals plus or minus, because we need two versions, the square root of 11 over 5. Now, I'm going to kind of go in depth here in a minute, and if you don't follow me, that's okay. We can pick this up later, but you at least need to get this in your notes. The problem right now is that neither of these have perfect squares, right? There's no square root of 11. There's not even anything that goes into 11. Same for 5. But the biggest issue is that when you simplify radicals, you are not allowed to leave a square root on the bottom. So we have to do what's called rationalizing that. We have to fix that. So to fix that, this gets kind of crazy. I need to turn that into a number that I can take the square root of. So I'm going to multiply this by the square root of 5 to turn that bottom number into the square root of 25. All right, just stick with me here. This is going to become now the square root of 55 over the square root of 25. Now I can take the square root of that number. The square root of 25 is just 5. So my final answer, if I go back, is going to be x equals plus or minus the square root of 55 over the whole number 5. And you can't divide those. You can't do that, divide that and get the square root of 11. I know that looks like it would be nice, but you can't. This is the final answer, though. And for those of you that are in honors, it's important that you pick up on that. All right, here's a quick set of problems in this other format. So the one thing that's nice here is this whole set is already grouped together, so it's a pretty easy thing for me to take the square root. Because if I take the square root of something squared, they cancel each other out, right? So if I take the square root while that is already isolated, the square root and square root are just going to cancel. I'm just going to get x plus 5. On the other side, I know that I need to get two answers, so it's plus or minus, and the square root of 36 we know is 6. All right, the only other thing I have left to do is to subtract this 5 to get x by itself. Well, the best way they write this, and I normally, like if you did that, you would put the 5 at the end. We can't actually subtract that. It's kind of hard to think about. There's really two answers there, so what I'm going to write is x equals negative 5 plus or minus 6. And then you just have to split that apart in your head to get your two answers. Or you can write it on paper, right? You can do negative 5 plus 6. Well, that's going to give you x equals 1. Or we can do the other option, which is, negative 5 minus 6, which is going to give me x equals negative 11. And those are going to be my two solutions. In that case, that's way quicker than factoring to try and end up finding that answer. All right, if we look at B, very similar. In this one, before we take the square root, we're going to have to get rid of this 3 out here, right? Because the 3 is not part of that square, so it's not going to cancel out. So I'm going to divide both sides by 3. That's going to give me x minus 5 squared equals 6. And now I'm going to do the same thing. Now that the square is by itself, I'm going to take square roots. That's going to give me x minus 5 equals plus or minus. There is no square root of 6. The only thing that goes into 6 is 2 and 3, and neither of those are perfect squares, so I'm just going to leave it as the square root of 6. Very similar to that square root of 10 we had at the beginning of the video. And now I'm just going to do the same thing. I'm going to add 5. That's going to give me a final answer of x equals positive 5 plus or minus the square root of 6. Now in this case, you can break that up to write two different answers, 5 plus the square root of 6 and 5 minus the square root of 6. But since we can't actually work out the square root of 6, we just leave those as two separate answers right there. All right, and real quick, I just want to show you this, talk about this last little reflect question at the bottom. It says, find the solutions, if any, to this problem right here. So hopefully you realize if you were going to do a first step, think about what it would be. And hopefully you would realize you divide by 2. That's going to give you x minus 3 squared equals negative 16. Well, when you go to take the square root here, you're going to be taking the square root of a negative number, which is not real. So you're just going to say in this case that you have no real solutions. And that's all you would do on that problem.